Hi, everyone. I just wanted to add one last thing to the lectures from last week that I had forgotten to mention, which is how old is the universe and how do we learn how old the universe is? So, the key to this goes back to our observation, or Hubble's observation, that almost all galaxies in the sky are moving away from us, and the further away they are, the faster they're moving. This, of course, is the evidence that first led us to think that our universe may have formed from some sort of Big Bang scenario. Because one way to get this behavior in galaxies is for everything to be moving away from everything else. That is, everything to be expanding outwards bigger. If you run back the clock, you can then imagine that at some point in the past, there was a point at which everything was on top of itself, basically. There is not necessarily a single point in the universe, but there was a very, very dense time when everything was much closer together than there is now. So the way you take this idea and based on the data from Hubble, calculate how old the universe is you ask how long ago these galaxies, given how fast they're moving away from us now, would have been right on top of us. So the equation for speed is that speed is distance divided by time. If you just turn that around and solve for time, then you can measure essentially how long ago these galaxies all would have been in the same place, which is when we think that there must have been a Big Bang. So solving for time gives the age of the universe. Using Hubble's original data, if you do this, you find an age of the universe of about 2 billion years. But over the years, over the decades, we've taken new data, we've learned to calibrate these observations better, and our most recent estimates give an age of about 13.8 billion years.